As we see in theory, how we can construct a confidence interval for a given sample around mu is given by this equation. In this Python code, we are constructing many confidence interval repeatedly. So let's see the code. In the first code block, we import the essential libraries such as stat module from SciPy, NumPy, Panda, and Matplotlib for plotting. In second code block, first we parameterize our Gaussian curve with mu 100, sigma 20, and alpha 0.95, which is correspond to 95% confidence level. Then we draw 25 different samples, each sample having 10 data points. In the next line, we create array to store results such as xmean for storing the mean of each sample and hf for storing the half width of confidence interval. In next line, we iterate over a loop for drawing different samples from Gaussian. So in the next line, we use the norm.rvs function from stat modules to generate random samples. Then we create a data frame for each sample and calculate the mean of the sample and also count the number of observations and assign sigma to the standard deviation values. Here we calculate the confidence interval with the non-dot interval function from stat module. It take three parameters. So the first one is alpha, which correspond to the confidence interval. Second is location parameter. For our case, it is the mean, and the third one is the scale parameter. For our context, it's standard error. Then we store the results in HF as this non-dot interval return a tuple, so it return two values. So we can store the half bit from this from the output of this function into the HF array, and then we print the value of the confidence interval width. So let's run the code block, and as we can see, it print 25 different values of confidence interval. In this code block, we are plotting the confidence interval. First, we choose the figure size, then we set the y-axis limit, which is centered at mu and extend to 1.5 sigma both sides. Then we create sample numbers, x label and y label. Then we plot the error bar for confidence interval with the error bar function from matplotlib. For x coordinate, it take the count of samples, and for y coordinate, it take the mean of each sample, and it create the error bar from the half width which we compute earlier. This half width extend both side of sample mean, and in the next line we are creating a true mean as a horizontal red line, and then we give a command for legend and to show the plot. Let's run the code block. So as we see, for n equals to 10, we get this chart, and we can see for some intervals the true population mean lie beyond the interval range, such as here. So we can do one thing, we can also increase the value of n to 30 to increase the sample size, and again run the code. So let's run this code block again and this code block once again. So here we can see that this chart is creating for the sample size of 30, And we have uh, here we have like some intervals. We just touch the population mean. So as it is drawn from the random samples, so we can run it once again to get a clear picture. So let's run it once again, and let's run this once again also. And here we also doesn't get a clear confidence interval which lie beyond population mean. So let's run it once again too. Yeah. So here we get a clear picture where we can see that that for a certain interval, true population mean lie beyond the interval, such as there, and also the width of confidence interval get also decreased here as we increase the sample size. In So 95% confidence interval does not imply that population mean lie an interval with 0.95 probability. Rather, it implies we construct many such interval. Then 95% of them will contain the population mean mu. Thank you.